and it's Tim Timberg for Canada with my colleague Geneva Grande McNeil. Mr. Hume, I'd like to review the various factors affecting freshwater survival with you, and then I'll turn to Mr. McFarlane to discuss marine freshwater survival. And going back to our conversation before the lunch break, can you summarize the factors that affect freshwater? Perhaps first, before we talk about egg to emerging fry freshwater survival, where do fish spawn? Where do sockeye salmon spawn in the Fraser River system?
In the Fraser River, most of them spawn upstream, tributaries upstream to their rearing lakes. A few of them spawn downstream from the rearing lakes, such as Choco Lake. And a few spawn in the lake itself, in the gravel beds along the shoreline. In most cases, that's just a few. There'll be a combination of upstream spawners and lake spawners, but in Cultus Lake, they're entirely lake spawners.
So Cultus Lake is unique in that it's entirely lake spawners?
Unique in the Fraser River system, yes.
Okay. And then, all right. And so then with that knowledge about the locations, what are the factors that affect freshwater survival on eggs to emerging fry?
Well, they're all affected by disease, parasites, predation, possibly lack of oxygen. In the rivers, they have another extra factor that would include high flood events, which actually just move the gravels, dislodge the eggs, and actually physically damage the eggs as well. And as far as both lakes and river spawners would be also affected by sedimentation. all right. And then if we move on to, if you could explain what are the factors that affect freshwater survival from emerging fry to smolts, and perhaps again, first you should talk about the location where emerging fry to smolts live. Well, they come out of, depending on where the eggs are deposited, the spawners, or the fry that is spawned in rivers will migrate, come out of the gravel and migrate either down to the lake or swim upstream to the lake, depending on where they were born. And then they'll typically they migrate along the shoreline as they disperse throughout the lake. And as the season progresses, they'll migrate offshore and into deeper water.
Okay.
And start undergoing vertical migration, so they'll actually migrate down deep water during the day to avoid predation.
And then you're talking about in the lakes?
In the lake itself,
yeah.
once they moved offshore. So this would be, say, a typical lake such as Shuswap. They'd migrate, they'd come out of the gravel in around late April, May, migrate along the shoreline, start moving offshore in early June, and by the end, through to the end of July, and then from July onwards, end of July onwards, they'd be out in deep water mostly.
Do some emerging fry to smolts not move to the lakes but stay in the river?
There is a river type of sockeye, yes, that such as the Harrison is the main example in the Fraser River.
And so that's a unique characteristic of the Harrison?
It's not unique to sockeye in general, but it is. I believe actually Widgeon Slough is also a river type sockeye. They basically come out of the gravel and migrate downstream immediately to the ocean, and undergo a very short time period where they smolt. They spend very short time in fresh water. Right.
And so can you then, for the assistance of the Commissioner, what are the factors that affect the freshwater survival in lakes and or rivers of the emerging fry to smolt stage?
Predation is obviously one factor. Food supply may be a problem if there are high densities or the lake is nutrient poor. which may not actually directly kill them, but may make them more vulnerable because they're slow growing. It makes them more vulnerable to predation for a longer time period, and therefore may actually increase the mortality rate. At the same time, they may also be more susceptible to disease. It's very hard to distinguish, to tell well, we do have very little information on diseases actually killing off fry because we can't observe that in the wild.
Okay, so just so I can get a list in my head, what you've said is that the factors that affect freshwater survival from merging fry to smolt are predation and nutrients in the lakes and disease. Are there any others, or are those the three factors?
Those would be, parasites also. They get there's a parasitic copepod which can affect some stocks particularly.
Okay. And when we talk about, I'd like to sort of talk about lake productivity then, with this nutrient point that you've raised. How do we understand lake productivity? What does that? How do we look at that?
Well, lake productivity is driven mainly by the nutrients in the lake itself. So most Fraser River lakes are in relative to lakes in general, say throughout North America, are quite oligotrophic. It means that they have very, very low nutrient levels. And this is fairly typical of sockeye rearing lakes, though, but it's atypical of lakes in general.
Okay.
But the nutrient level, the level of nutrients that are available determines how much phytoplankton can grow, and that in turn controls the zooplankton which the sockeye feed upon.
That's their food at that stage.
Yeah.
And is that what we call a bottom-up process?
Yes, it is.
All right. And how, with that description of lake productivity, how does predation fit into this?
Predation is a top-down process.
What does that mean?
It means that it's the bottom-up process. It means that the production of the fish are controlled by things coming from the lower trophic levels and nutrients. Top-down means that a higher trophic level, such as predatory fish, piscivorous fish, feeding on them control the abundance of the sockeye, the fry in the lake.
Okay, and then if we could then return to we have Exhibit 45, and perhaps we could have this marked as the next exhibit. That was tab 45 for the record. So looking at Exhibit 810, can you just help us understand what the X and the Y axes shows here?
The X-axis is effective female spawners. This is a graph of Quesnel Lake in Quesnel Lake. So the bottom axis is effective female spawners and millions of fish, starting goes up to 2 million fish on the right-hand side. The Y-axis, the left-hand axis, is the number of fall fry, estimated abundance of fall fry done through our acoustic and midwater trawl surveys.
All right, and what does the red square show us?
Red dot is the results of a model that we've built showing based on the primary productivity of a lake, and the model does is estimates the carrying capacity, optimum escapement to a lake, and also actually what it really estimates is the optimum is the maximum biomass that a lake can support, and then it uses some rough numbers to estimate the optimum escapement to the lake that would produce that biomass. And
Right.
then as further using an average fry size, we can actually then turn that into estimate the total number of fall fry or smolts that would be produced by that optimum escapement.
And so in this instance, what does it tell us about Quesnel Lake?
So from Quesnel Lake, what we're suggesting is that we can produce, the lake can support about 60 million smolts, and it would take approximately, it's hard to put
And where are you getting that from? Is that the star, or is that the...
No, the 1.5 million, sorry, I just multiplied effective females by 2. So males, and so total returns to the lake would be 1.5 million.
Okay.
But the graph shows 750 female spawners.
All right. And then if we could turn to the next page on this exhibit. And if you could assist us to let us know what this graph shows us. Is it...
Okay. We've applied this, our PR, well, we call it a PR model, our photosynthetic rate model, to, and we've applied this model to many of the Fraser River's sockeye rearing lakes. And those are the blue bars in this graph, so they're showing the, when we're presenting the data in this case is a number of spawners per hectare lake surface area, so that we can compare all the graphs relative productivity of each lake to each other.
So you've done this for 18 sockeye lakes?
Yes.
And should we be careful about the green bar? What does the green bar says maximum observed spawners? That's not an average. Could you explain?
It's not an average, no. It's in the last 20 years when this is the maximum observed spawner ever that we've seen for each one of these lakes.
All right, and so if the blue bar is tall, like take for example Anderson Lake, and the green bar is low, what does that tell us?
And Anderson Lake is capable of a spawner density of about approximately 100, 110 spawners per hectare. And so far, we've only, in the last 20 years, we've only observed about 40 spawners per hectare in that lake.
And that was the maximum observed?
That's the maximum observed, yes.
And do we need to consider the fact that these salmon co-migrate when we look at this chart?
It's one way of looking at productivity, relative productivity of various lakes, various sockeye conservation units. And so in this case, say, Shuswap and Cultus Lake as an example of two stocks that migrate at the same time. And Cultus Lake is obviously, in recent years, has not produced anything near its capability, whereas Shuswap has at least 1 year which is well over its estimated carrying capacity.
So fisheries management, they have to balance those lakes out to ensure that you ensure sufficient returns in each lake.
This is one measure of that. Stock productivity is partly due to freshwater factors, but also marine survival, marine productivity would affect it as well. This is just one factor that goes into the whole mix.
Okay, thank you. I'd like to then move on to the question of now moving from smolt to the marine water.
Is this graph on the screen part of Exhibit 45? That's for Exhibit 810?
Yes, it's the second page. And Mr. Hume, then earlier before the lunch break, we were talking about smolts to marine, and you talked about the need for further data on that information. I'm wondering if we could turn, Mr. Registrar, to Exhibit 804. This is a document that Commission Council entered this morning. If we could turn to page 37. And I understand that this graph shows on the left side smolt to recruitment survival. So that's outgoing smolt. And then their returns as adult fish on the left-hand side. And then on the bottom, it's the brood year. So that's the year that the eggs were laid.
That's correct.
And so how does this, what does this graph tell us about freshwater to marine survival from smolts to recruitment returns?
It shows a number of things. One is it shows that the Cultus, if you look at the Cultus wild boat chart line, which is the solid black line, and compare that to the Choco line, you can see that they vary fairly well together. So that it appears that maybe mortality factors that affect one are affecting both stocks at the same time. Secondly, it can show us that for choco, survival has been slowly decreasing over time. So it started off in 1999 at approximately 8% survival, and it's decreased now down to 2005, which is the brood year in question for the inquiry, to well less than 1% survival.
Thank you, Mr. Hume. I'd like to now turn to discussing marine survival rates. And Mr. McFarlane, can you describe the most vulnerable stage for salmon in the marine waters?
I believe the most vulnerable stage is immediately upon ocean entry, probably within the first 4, maybe 5 weeks.
And so where would that be? That would be in Georgia Strait?
For these stocks, yes.
Why is that your opinion?
I'm not a salmon biologist, but I think it's becoming generally accepted that this is the case. There's been a fair amount of recent work on it's called the critical time, critical period hypothesis, which indicates you sort of have to make it or break it very early in your ocean career. Not unlike us.
What's your opinion on the causes of decline then of the Fraser River sockeye salmon in 2009?
From the evidence I've seen, I believe that the problems were with the Strait of Georgia system in early 2007, and it was related to a very low productivity of the strait. And by productivity, I mean the same as Jeremy just explained for freshwater. It's the lower trophic level success of the feed.
Okay, so there's a sort of nutrient issue. What are the species in the Georgia Strait that are competing with sockeye salmon when they enter the marine waters?
Well, the dominant species that would be considered competitors would be herring, chum, pinks, although in 2007 I believe that wasn't a major pink year. You would also have other species such as Chinook and coho.
Is that the only other species competing with sockeye salmon in the Georgia Strait?
Probably not. There are other species which their early life history stages would also eat much of the same types of food, and that would include things like Pacific hake. There's 2 other small, what you could consider forage fishes, which have a fairly significant abundance, we think, although there's been virtually no work done recently on them. One called a Leuroglossus, one called a Myctophid or midshipman, and they are there in fair quantities in the midwater. They're not right at the surface like these other species.
I think for the record, somebody's going to have to spell those words or provide them in writing after your oral testimony. So we'll do it after your oral testimony. We'll get that in writing to help the record here.
Okay. I know how to spell them, though.
Well, we'll keep moving.
Okay.
And so going back then, in the spring of 2007, what was your understanding of the ocean entry of the sockeye salmon in the Georgia Strait?
Well, again, this is from other people's work, but the data I've seen indicates that the overall abundance, and this is based on trawl surveys in the Strait in around June and July, the overall abundance of these species was reduced. And we're talking all of these species, not just sockeye, and that the condition factor of these smolts, so that you could think of it as their robustness, their fatness. It's a relationship between the length of a smolt and the weight of a smolt. Whereas the lowest on record for many of these species. The same applies to herring. The juvenile herring were extremely in extremely poor condition, and this generally relates to ability to survive through the critical period of time that predation might have an impact. So the important thing is, I think, that you might want to take from this is that when you have fish in a poor condition at this time, you'll see some immediate types of mortalities, but it's also indicative that there'll be mortalities following this time. It basically says they're going to be in a bad state, so they all don't die on the same day. They may continue to die over the next number of weeks, possibly even a number of months, because like other animals, as they get sicker or don't respond to any other food sources, they can't make it.
Okay. And do you have a recommendation on how to better understand this early entry of sockeye salmon into the Georgia Strait?
Well, if you mean...
What more information would be of assistance to understand this?
If you wanted to design a program that looked directly at the relationship between sockeye, smolts, and some of these factors we've been talking about in terms of predation and competition, and how, whether it's a bottom-up or top-down system, I would design the survey to go out there at the specific time. So this would be, I would look at it in early spring to early summer, so let's say April to June or early July. Mm-hmm. And I would study all aspects of the system at that particular time. That would include the physics of the system, wind patterns and nutrient patterns, which would give you a initial indication of productivity levels. Study the lower trophic levels, which is again the feed for these species, and then study these species themselves, the upper pelagic species, which are the salmon species we mentioned, herring. I'd also look at the other potential predator species, mm-hmm. which Vili and Andrew Treitz had in their report, which would include things like hake, dogfish, pollock, and but I'd also look at some of the other potential competitors, which would include the other species I mentioned, such as Leuroglossus and Myctophis. Now, so you're making a very directed ecosystem type study to answer a very specific question. So you're not going out there. It's not like the ERI program is designed to look at, which is a much broader approach.
I note that the report recommends further data on 6 species, of which 4 of them are not located in the Georgia Strait. The report only recommends further study on river lampreys and common mure. Would you care to comment on that? Or would you add to that list just as to
I would
what else?
add to it. This list is, some of these potential predators occur in waters just north of Georgia Strait and on up towards Alaska. So if you're looking at it through its whole life history, I think you would want to examine those species and others in those other areas as well. So these would be in addition to what I said for the Strait of Georgia.
Okay, thank you. And you mentioned dogfish and pollock.
Yes.
Could you perhaps describe why we would look at pollock in the Georgia Strait?
It's a species that's present in the strait. It tends to be in the southern part of the strait, and it is a fish eater, so that it is a potential predator. It has been identified. I'm not suggesting it is a predator of any consequence as far as sockeye are concerned, but I think when you're looking at trying to answer the question you are, which is what happened to these sockeye once they entered ocean waters. You want to examine all the potential predators. So that this is why I would conclude it. Remembering that when they enter the water, there's a lot of mortalities going on for a fair amount of time. So we're looking at, I don't think anyone would disagree that salmon are being eaten by a number of species. That's just the way it is in this world. The question is are these species having an impact on the dynamics of those salmon? And my belief is that it is a bottom-up situation, which is a productivity-controlled area. But in order to actually ascertain that, and in order to study that into the future, you want to look at both top-down and bottom-up. A program such as I just said would give you that ability.
Okay, thank you. Before we move off of the recommendations, recommendation number 3 on page 83, it's the third paragraph, calls for a central diet database. Do you have any comments with respect to that recommendation?
My comment would be that to begin with and to get it off the ground, number one, I agree on central databases. I think it would be a good thing. But I think the best way to go about this would be to have it as an actual metadatabase where you identify what data there is, the area of whatever data you have is taken, and the custodian of the time frames that are available, and the custodian of that data, and the contact information for that custodian. I think that would give everyone access to what they need. It would let them know what's available, but it would also ensure that the proper explanations came along with the data, how it was taken, all those sorts of things, and probably, I would think, lead to collaborations. I've certainly done this type of thing with other data sets, and I find it very useful.
And before we move off of the recommendations, did you have any other comments on the other 4 recommendations?
Well, I certainly agree with the next one, as we just talked about, which is focus some of this salmon research work once the fish enter the sea. So no argument there. And conceptual ecosystem model, sure. I mean, I do that myself. I actually worked with some of Vili's students on these types of things, and it's always beneficial.
So perhaps you, just while we're on that point, could you describe some of your work using ecosystem models? Is that something that's being utilized by DFO?
Ecosystem models are being utilized by DFO, yes. I've participated in studies using EcoPath with EcoSim, which is the model that is recommended here.
And just perhaps we could then turn to, Mr. Registrar, to tab 20 of Canada's list of documents.
Dr. Perry and Dr. Masson are both co-chairs of the Strait of Georgia Ecosystem Studies Initiative.
Okay. And can we turn to the abstract at page 3? And this abstract, perhaps you could just tell us what this document is first, just in general. I know it's a draft document. What's your understanding of what this CSAS document is intended to do?
Could you show me the title again, sorry, so I can tell you what it is? It's okay. This is the actual working paper for the Strait of Georgia ERI, building the framework for the ecosystem approach.
Mm-hmm. So perhaps we could turn to page 3 of the abstract, may help.
Okay.
As I understand it, this document is summarizing the ERI project that recently concluded. Is that?
This document would be, yes, this would be basically, because the ERI project isn't actually concluding for another, or I guess it just concluded in the past month, but this would have included all the knowledge, all the information up to that point on the various programs that were going on at the time. I believe it also will provide a series of recommendations and that sort of thing, and establishing an actual providing an actual framework for future work.
Okay. If this could be marked as the next exhibit, please.
Exhibit 811.
I understand this is a bit of like an executive summary of that document. Is that correct?
Yeah, this is a science advisory report, which basically pulls what the subcommittee that reviewed the previous document would consider the major points that should go into a document for easy access for everyone, not just science people.
Okay.
So it gets rid of a lot of the science and concentrates on the actual conclusions and recommendations.
And if we could then have this marked as the next exhibit.
Exhibit 812.
And if we could turn to page 8 of this document. And if we could, I'd like you to comment on the knowledge gaps identified by DFO in the executive summary.
Yep, those are knowledge gaps.
All right. And then if we could then turn to the next page to conclusions and advice. And so these are maybe we'll just let the document speak for itself in the interest of time. And I just note that the next page, at the bottom of the page, there's recommendations. And I'm not sure if you've had an opportunity to review the recommendations.
Yes, I have. I would say that in the previous part that you just skipped over, there's a timeline there that I think is very important.
Okay, if we could perhaps go to that then.
It goes from short-term to mid-term to longer-term research type approaches, and I think it highlights a pretty reasonable approach to trying to determine what we can expect might happen in the Strait of Georgia over the next number of years. I do agree with some people who suggest that this is possibly DFO has not been putting enough effort, and by effort I don't mean of individuals, I mean of money.
Mm-hmm. But so this then is part of the science
This is the science operational plan, basically.
Plan to move forward in the next 5 years.
Yes.
Okay, thank you. Do you have any comments with respect to the recommendations?
Well, I do in terms of, I think they're excellent recommendations. They seem to be in the order that follows the previous plan, the immediate, midterm, and longer term things that should be worked on. And I particularly agree with the recommendations 1 to 5, which is the synthesizing of the results right now, but basically to get into the evaluation of selection and evaluation of indicators and monitoring programs, the operationalize of collection of data, which is always difficult to keep that sort of thing going, and the development and evaluation of the models developed under this initiative.
Okay.
That includes linking these models together from the physics right through to the higher trophic levels. I think that will generally lead to the final approach, which would be to bring together the appropriate people from all the different stakeholders, mm-hmm. and people who are interested in the Strait, and you can then from there get their ideas for setting out the objectives for how you would actually build an ecosystem management approach. This is basically an ecosystem assessment approach, not a management approach. So this is the science that goes into the management, but it does not incorporate the actual management objectives or how it would be implemented.
We could then turn to tab 37, Canada's list of documents. And this is a document, Pisces Scientific Report number 25.
Yes.
and it's an international program on climate change and carrying capacity. And were you a co-author of this work?
Yes, I was.
And this could be marked as the next exhibit.
Exhibit 813.
And if we could turn to page 1, there's an introduction here. For the assistance of the Commissioner, can you, first of all, can you perhaps describe the larger work of which this paper, I understand, was part of the larger work?
This is a, well, basically, it was conducted by a task team under the auspices of Pisces. The task team was called the Basin Scale Studies Task Team, or BASS. It was it looks at the two North Pacific gyres, the Eastern Gyre and the Western Gyre. Now those fall within, you can see ESA and WSA on the map.
And this is work that's international, is that correct?
Yes, it is. It's joint work between the 6 Pisces nations.
And okay, we can look those up. And
Well-
so just before we get into the details of this,
Yes.
so what is how do those 6 nations work together in doing research?
The 6 nations get together and discuss research, formulate plans on where the most benefit might derive from doing certain types of projects together. It doesn't really support research itself. The individual countries still continue to do their own research. This is more of a guiding group that allows people to get together to develop their thoughts and to actually develop some joint programs for information exchange and that type of thing.
All right, and so I'm just cognizant of time, but if you
Yeah.
could just give a quick overview of the intent of the project, and then we're going to jump to the conclusions.
Okay. The project was set up because it was recognized by the 6 nations of Pisces that a lot of things were going on in the 2 gyres, the Eastern Gyre and the Western Gyre. So why don't I just skip to the Eastern Gyre right now, because you can use all the same stuff for the Western. It's very productive areas in the open ocean. It's a tremendously important rearing ground, or whatever type of ground you want to call it, for salmon. And it seems to respond to the same decadal scale type shifts or regime shifts that the coastal areas respond to. The people sitting on the BASS task team felt that it would be very useful to bring together as much information as we could on those gyres, to build some conceptual models, and then to take it one step further and try and build an ecopath with EcoSim, ecotrophic model of the gyres, with the hope that we would begin to understand how these gyres might influence coastal systems, because they're almost certainly linked.
All right.
And that was the intent.
Okay, if we could then turn to page 37 of the document. What was the conclusion as it relates to predation, and specifically with salmon, in this report?
Well, the conclusions were very similar to the conclusions in technical report number 8 here, in that there's a lot of information that is required still to ensure we have an understanding of the system, that there should be some directed studies on specific aspects of species that were out of the modeling exercise that appeared to be possibly of quite a bit of importance, and that the improvements to the models require that type of information, both diet information and abundance information.
All right. And a note there in the first paragraph, it says we needed better data on biomass trends for as many species as possible, especially competitors and predators of salmon, such as flying squid, pomfret, and sharks.
Right.
Okay. And then over the page, it references a table at table B4, which is at page 56. and this is where they recommend additional species that need more data. And perhaps you can just briefly tell us what this table tells us.
This is simply the groups of species, or the species or groups of species that were used in the model. It is the table indicating the data quality as we determined it to be using the data pedigree model, which is basically assigning a number to it that says we either think the data is very good or very poor. And in this case, the colors represent how we felt about that data, ranging from very poor, which is red, and excellent, which is green.
Okay, thank you.
For the record, Leadham initial T, appearing for the Conservation Coalition. In the limited time that I have available to me, I wanted to focus upon ecosystem-based management and talk about how that can be achieved. And I realize that we're supposed to be talking about predation, but we seem to be talking more at generalities when we're talking about ecosystem-based management. So I want to focus upon that because I found the discussion in Project A, particularly at pages 77, 78, and 79, to be very informative. And so, Dr. Christensen, I'm probably going to start with you and then get some other comments from the other scientists on the panel. And I think it's important for us to understand the why. Why should management be focused upon the ecosystem and not just simply managing the sockeye from a sustainable aspect?
Well, first of all, thank you for the question. I was wondering whether I would get any. Management should also focus on sustainability aspect of. That's clear. And that is where we have our traditions for, that's what we have tradition for emphasizing. But it's also quite clear that that cannot answer what has happened to Fraser River sockeye over the last decade or 2 decades. All indications are that marine survival has been declining. That's what we've heard here. And we are in want of good explanations for that. That by itself is a good reason for looking at what happens at the ecosystem level. So it's really to try to understand that and also to see what management actions might be taken. To me, that's important reasons.
And I suppose the question comes down to this: do we know enough about the ecosystem to allow management decisions to be based upon our knowledge of ecosystems? Are we still in the learning phase about the ecosystems, or do we know enough? Do we know sufficient amount so as to enable managers to start to incorporate ecosystem knowledge and values into their decision-making processes?
You look at how this has progressed in Canada, it certainly looks like we don't know enough. I compare to other countries, and I see Canada not being a leader, to be very diplomatic. Rather, Canada has provided intention that is going to take that direction, but not follow suit as far as I can see. We need to try. We need to start doing it. We need to start making the analysis at the ecosystem level. Certainly a lot of work has been done on this. By doing it, we become better at it. We ask the right questions. We find out what kind of research is needed, what kind of data is needed. We can't just wait until it's perfect. That means it will never happen.
Right. I'm looking at your report at page 79, Dr. Christensen, and the next to the last paragraph that begins, overall, Canada has not moved very far towards ecosystem-based management. And then you go and draw some comparisons between U.S. and Canada, and then you further then go on to say, at the very end of that paragraph, Australia is possibly leading on implementation of ecosystem-based management, and has done so by initially, in quote, letting the policies move ahead of the science, end of quote. And I really find that interesting. And I'm going to see if I can get some understanding of what you mean, or what Mr. Smith meant when he communicated those words to you of letting the policies move ahead of the science. And let me tell you why. Because in my mind, maybe I have this all wrong, we have the wild salmon policy, which says that there will be ecosystem indicators. Strategy 3 of the wild salmon policy deals specifically with ecosystem values and indicators. And so it seems like we have the words and the policy, but we don't seem to be moving ahead. Okay, so with that background, maybe you can explain how you let the policies move ahead of the science.
What happened in Australia was that a senior colleague there, a scientist called Keith Sainsbury, was quite influential in impacting the policy there. And he talked to people, he explained what is involved in what we here call integrated management, so multi-sectoral management of the oceans. The politicians listened to him, and they basically made policies that implemented this. Then the scientists were really forced to move very, very quickly. They had to adopt quick approaches for guiding the actual implementation. And they asked much bigger questions after this happened. They had to take a number of shortcuts, and they burned their fingers a few times. But the outcome was quite clear, that they are now a leader in this field. And, sorry.
But if I can draw it back now to a discussion about Canada and the wild salmon policy, because you're familiar with the wild salmon policy, are you not, Dr. Christensen?
Not in details, but I have looked through it, and I have an idea about what it covers. But
Right. And you're aware that it sets out mechanisms for determining benchmarks and conservation units in order to preserve biodiversity of the salmonid species, and then goes further and talks about habitat and how you need to have habitat factored into the wild salmon policy. And then goes a step further and to strategy 3, which talks about the need to incorporate ecosystem values. So you're not just looking at the salmonid species, but you're looking at them in the context of the entire ecosystem. All right, so if you can accept that that's a very brief synopsis of the wild salmon policy, and we have that in place in Canada, how do you see us falling flat? Because we seem to be we seem to have a policy in place, and yet at the same time we don't seem to be making much progress on it.
Ecosystem-based management is not a question of measuring the temperature and adding an indicator and saying we are considering the ecosystem. It's much more a question of how do you deal with trade-offs. These trade-offs involve interest groups which are going beyond what we normally look at. It's not just a question of the traditional way of making management. Trade-offs involve that you have to make choices. You need to make clear objectives for the management. You need to consider how you evaluate different stakeholder groups, different interest groups, that there will be conflicting outcome of this. It has to be much wider, and these things have to be explicitly considered. The interest groups have to be clearly involved in the definition of how you do this, how you set the objectives, how do you deal with trade-offs. That needs to go in, and that's hardly scratched as I read the wild policy, the wild salmon policy. The surface is hardly scratched.
Okay, I'm going to allow the other panel members to comment on any of the discussions so far. Mr. McFarland, do you want to add anything about how do we move forward in terms of developing ecosystem-based management for the salmonid species, particularly Fraser River sockeye in Canada?
In terms of ecosystem-based management, I would have comments. In terms of how we do it in relation to Fraser River salmon, I probably would bow to people who actually study those types of things, although I did outline how I would look at it from a science perspective.
Yes.
I agree with what what Dr. Christensen just said in terms of ecosystem assessment versus ecosystem management. They're basically two different disciplines. Ecosystem assessment is the science part of trying to understand how the ecosystem works, the functional aspects of it, whereas ecosystem management is the how you protect the resilience of that ecosystem given the various demands made on that ecosystem by various groups. So, as he said, that the trade-offs are really the bread and butter of how you manage the ecosystem, and it requires the people really wanting to work together to do that, and so you have to have the right people in the room. They have to really be serious about trying to come to a consensus on what trade-offs are reasonable in order for everyone to benefit, as well as for the Strait of Georgia to maintain its resilience. So we're not there yet. We're not even close to ecosystem management. Fisheries, ecosystem fisheries management, we're progressing on a little bit, but ecosystem management, we're very far away from that.
Are we somewhere along the track towards the developing knowledge of ecosystem assessment?
Yes.
You make the point of bifurcating ecosystem assessment and ecosystem management.
Yes,
so
I do.
Surely we're somewhere along the line in
Absolutely.
the track of determining what the ecosystem is like. Even though it may be very complex, we can do energy analyses, we can do water fluxes, we can do all kinds of things that are crucial to our understanding of the trophic levels in ecosystems. So somewhere we're along that pathway.
Yes.
So have we advanced sufficiently to enable managers to then take the next step and to start to incorporate that knowledge into developing these trade-offs, as you call it?
In my opinion, we're progressing nicely along that line. Again, if you're thinking managers as fisheries managers, that's only one component. There's many other components to land use and
Right.
Those types of things that have to be incorporated into those decisions. Setting up a marine protected area or a marine park or a terrestrial park on the shores of any of these systems requires a whole different group of people to come in and start being part of the whole dynamic.
So doesn't it come down to this, that the problem is that we're really isolating Fraser River sockeye, and we're saying, well, if we're just simply going to focus on Fraser River sockeye, we'll manage them in this way. But you're telling me you can't just take the fish out of the water, because if you do that, you take the fish out of the water, it's going to wriggle around for a while, but then you're going to lose whatever value the fish might have. So you really need to put it all together. Is that what you're saying?
I don't remember that, actually. I'm sorry. Maybe the fish out of the water part is where I started to
Well,
lose
forget
it.
my analogy then.
Okay.
Just drop my analogy. It was
All right.
probably a weak analogy to begin with. I was just trying to strive for just some way to describe the fact that if we simply focus upon the Fraser River sockeye as a single aspect, we're going to be missing a great component, and that's all the ecosystem-based values that you know about.
Yes, in terms of if you're going to use just the Fraser River sockeye as your basis for managing all of the Strait of Georgia, that I don't think would be anyone's intent. But if you're looking at answering very specific questions, you can design programs incorporating the ecosystem assessment and eventually the ecosystem management approach to answer very specific questions. But there would also be a total approach for the Strait of Georgia. But people have talked about the spatial components of these things, setting up marine reserves and things. Where do you place log booms? Where do you place aquaculture sites? Those are all components of ecosystem management, but they have to be based on some knowledge of those areas, In this particular case, we've been talking about the Strait of Georgia and the Fraser River sockeye, so you would try and use that information, develop information bases for those things. For other questions, which are also part of the ecosystem approach to managing the Strait of Georgia, you would require information on those types of things also, absolutely.
Mm-hmm. Dr. Christensen, do you have any other comments? I know I'm running late on time. Dr. Christensen, just one last comment from you. You've heard the discussion around ecosystem assessment, ecosystem-based management. Where are we along that paradigm, in your view? Are we very far advanced?
In Canada in general, or with regard to Fraser River sockeye? Or both?
With regards to Fraser River sockeye, because that's the question in the room.
May I step back and just make an observation based on the experience I got from this work that I'm engaged in here? I started out here, I was definitely not a salmon expert. I know how to work with food webs, that's where my experience is, how to evaluate numbers. So I basically had to review what's known about Fraser River sockeye all the way from spawning till they come back again, the whole process. And in doing so, I came across a quote from David Starr Jordan, who was the first president of Stanford University more than 100 years ago. He was also an eminent scientist, and he was quoted for saying that to evaluate the knowledge about sockeye, the sockeye leaves the fresh water and they go 10 miles offshore and they stay there for two years until they come back again. This was pointed out during this process here as illustrating how far we have moved in 100 years with regards to knowledge about sockeye salmon in general. However, when going through the material that's available, looking for data about numbers, predation, what we know about that whole life cycle, I really got to question whether we have moved very far beyond what David Starr Jordan described from more than 100 years ago. The questions we heard from the Council for Canada all dealt with freshwater and the coastal zone. But the 2 years they spent offshore were not even touched upon, apart from the study, the BAS study, which, however, didn't produce numbers that were useful in this context here. That was not the focus. So if we are going towards ecosystem-based management with regards or in understanding the ecosystem of which the Fraser River sockeye salmon are an important part, we need to look at the whole life cycle, including the ocean phase. We need to know much more about what's happening there. And we need to also make it very clear what it is we know about that. And I would say we have not moved very far. Normally, I make models which are quantified with data. I tried to do that here as well, but there were just too many unknowns. There were too many unknowns for me to want to stand here today and defend those numbers. That's why I didn't do it. I tried.
Right.
So I don't think we have moved that far in those 100 years.
Right. Thank you. I could carry on all afternoon in this kind of discussion, Mr. Commissioner, but unfortunately my time is limited, so I will have to leave the podium.
Thank you very much.
Thank you, Mr. Lederman. Would this be a convenient time to take the afternoon break?
And we'll now recess for 15 minutes.